Hello, everyone. Thank you for having me today. Uh, my name is Drew Hohman, and I am from NASA. I am a scientist at NASA, and I will be talking to you today about one of the greatest questions that this generation has had. And that question is there extraterrestrial life on other planets? And the answer to that question is yes. It is yes because of fact and tons of research that has been going on for years and years and is going to keep going on for more years and years. Um, it's not because aliens are not real because of all the conspiracy theories like the aliens did build the pyramids, or the stories we get from the crazy people that they say they've been taken from a UFO and probed and all that, or the Illuminati. There is life on other planets due to fact, and they are nothing like what these aliens that people are talking about. Um, One reason why there is life on other planets is that there is water in space. Another reason is stellar storms are lighting up signs of life on alien planets. And the last reason is there's a new test that one of my colleagues, Mr. Yuka Fuji from NASA, has been working on, and that test is a test for alien habitability. That's a hard word for me to say, but habitability, alien habitability. To touch back on my first point, the water in space. Um, we have water on Earth, and water is the basic ingredient to sustain life. And scientists, my colleagues, have recently found that there is way more water in our solar system than we originally thought. Um, we thought that water in space was really scarce, but it turns out to be that there is a good amount of it, a lot. On Europa and Titan and Cyclades, if I'm saying that right. They are moons on Jupiter. They're moons for Jupiter, and we recently just found out that beneath their surface there are vast oceans. And like I said, on Earth we have water that sustains life, and if there's water on these moons and planets, then most likely than not there is life being sustained, and we will find it. Um, NASA has a rover, which they call Curiosity. I actually named it Curiosity. I was the one who named it. And it's found carbon containing organic molecules and fixed nitrogen, which is the basic ingredients for Earth like life. And we found that on the Martian surface. So that was a very big breakthrough for us. Um, Another point I have is that stellar storms are lighting up signs of life on alien planets. Stellar storms are eruptions that hurl clouds of stellar material and radiation into space from young dwarf stars. And they are helping us potentially search for habitable environments in space, like planets that we will be able to habitat and have they have water and basic ingredients and basic molecules that we have on Earth. Um, if these charged particles that these storms are giving out interact with an atmosphere of a planet that contains basic products of life, which are water vapor, molecular nitrogen, and oxygen, the interaction could trigger a cascade of chemical reactions that form atmospheric beacons. And these beacons are related molecules in the atmosphere that are easy to identify since they send off strong infrared signals and in response to energetic particles like stellar storms. So when these stellar storms interact with these beacons, they send out a infrared beam that we pick up on, and it's easier for us to rule that planet that has a molecular storm and the beacons to be more habitable because of all the energy and all the buildup on that planet. Instrument called SABRE. It stands for Sounding of the Atmosphere Using Broadband Emission Radiometry. It uses the very same chemistry that generates the atmospheric beacons, and it occurs on Earth's upper atmosphere in response to the beacons and everything. My last reason for life on Earth is there's a new test for alien habitability. And what that basically means is that worlds that are like Earth's, that are within a star's habitual zone, have a stable atmosphere and are able to contain liquid on the surface. So, just like Earth, we're able to contain liquid on the surface with our oceans and lakes and our water. Now, if planets start to develop this, start to be able to contain water on the surface, we know that that planet is habitable and there's probably life on it. A new study led by my colleague, Mr. Yuka Fuji, of NASA's Goddard Institute for Space Studies, has made a three-dimensional model, and it's accounting for global circulation patterns. And global circulation patterns are described as the worldwide system of winds by which the necessary transport of heat from tropical to polar latitude is accomplished. Now, in each hemisphere, there are three cells: the Hadley cell, the Ferrel cell, and the polar cell, in which the air circulates through the entire depth of the troposphere. Now, this test he's creating is he's looking at these planets, or the planets that are habitable, and he's reading the global circulation. And if it's great enough, then it is able to sustain life. And liquid water is essential to life as we know it. If a planet does not have the sufficiently warm atmosphere in order to maintain liquid water for a sufficient amount of time, then it is unlikely that the life will not be able to emerge and evolve. So what we are looking for is planets that do contain water and do contain carbon and oxygen, not oxygen, but carbon and molecular sources. And we are exploring and looking at these planets. Like I said, there's been a lot of research going into this, and there's going to be a lot more research. But I have a very good feeling that more likely, sooner than not, we will find life-like organisms on different planets. It's just inevitable. So, thank you for having me. Thank you for letting me share my ideas with you. Have a great night.